Hi there, thank you for joining us again on this channel. The whole world has been taken over by COVID-19 fever, but we've decided to channel the negativity into something a little bit positive and talk about personal protection devices for healthcare workers. Thank you for everyone that supports the channel. If you want to be kept in the loop, then click that subscribe button. And if you want to be notified, then hit that little bell as well. If you like the video, give us a thumbs up and please share this widely. I think this might be something that could potentially save someone's life somewhere. So today I'm speaking to Retief. Welcome. Thank you very much for joining me.
Thanks, Dr. Etienne.
When this whole viral pandemic started, I realized that we are not going to have enough protective devices to take care of our healthcare workers. And I put a post on Facebook to put a bit of a challenge out there to say, I'm looking for people to work on a design of a personal protective device that we could use, that would be reusable. It needed to be lightweight. It needed to be made with locally available components. It needs to be affordable, and it needs to be made available within a 4-week time frame. And at least two very serious industrial design companies came to the front and they said, listen, we feel up to the challenge. And I think Retief focused on getting something that we can get available very quickly, that we could potentially make in a very informal setting. So Retief, maybe just tell me, how did you decide to become involved in this?
Yeah. Thanks. Some of my friends reposted a social media post where you asked about innovative people that could assist at personal protections for the medical people, and it immediately sort of came to mind that, oh, this is quite a nice challenge. Being a designer, looking for challenges, this was an ideal challenge. And I think the whole request for local manufacturer or local contribution from a maker or some of the smaller manufacturers really intrigued me. As a designer, a design is one thing that you do, but the other part of a design is how do you get it made and who's involved in making and supplying material and components. And being around Western Cape, I know a lot of the smaller manufacturers and industry, and immediately a couple of options came to mind, and I thought this is quite a nice challenge. Let's try and do something quite quickly, something professional but affordable and within the range of the local guys.
This is the product that you've designed, so maybe just quickly explain to me, how does it protect me from becoming infected?
Yeah. Okay, so the components of this product is mainly an air supply unit, a unit that actually pulls air through a pump into a mask there, and the mask fits quite tight over the person's face, and there's positive pressure of air onto the face of a person. So it prevents you from breathing in air that is not filtered when in a situation where there might be contaminated air around you. So a little motorized fan pulling through two filters on the back of the person, an air supply tube that brings the clean air over towards in the mask, and the mask sitting on top of, sort of onto the face of the healthcare worker.
Okay, so there are commercial products available to be imported that works in a similar fashion. Firemen uses them, mine industry uses them, and certainly from the medical industry as well. But the issue with this is, can this be produced without needing to import anything?
Yes, we can. If we look at the mask design is based around foam, and this is medium density foam. In our house, we use it as our little camp mattresses, and that's the idea was to try and reuse that. This is a commercially available product, and there's various grades and types of foams available. What makes the foam nice, firstly, it gives you a structural rigidity, which you need to actually be able to construct the mask. But the second part, it actually allows a little bit of deformation as it needs to go onto your face, and not all heads are the same. Then obviously some PET, and there's various types of PETs available to actually make a visible protective shield. And from there, 3D printed parts. And we use 3D printed parts as crucial structural connecting components at various points in this mask. 3D print is a fantastic method of producing small or plastic parts. And the nice thing is you can print stuff which you can't mold. So for instance, our little inlet here, to actually make that into a production-friendly one, you would change the design. But for a 3D printed version, this is ideal. It's a straight-up print, simple, very little support. So, yeah.
Okay. And so in principle, this mask consists of a flat sheet that's been cut out, another flat sheet that's been cut out, and a third one that fits together, gets clipped together. These tubes are available in any hospital that's got anesthetic machines. We throw them away every day. But in theory, because someone's not breathing in and out through the tube, they can be used for quite a length of time. And then this connects up to basically an air blower. So what are the specifications of this now?
So our unit basically supplies about 80 liters per minute.
So obviously you bought the filters. These are commercially available FFP2 level filters. So basically the same as an N95 filter, but there are two of them. So it distributes the surface area a little bit.
On the intake.
And then there's a 12 volt DC motor in here.
That's right.
Which obviously you don't 3D print.
No.
And then there's a little battery pack with...
on the back there's a little battery pack.
With basically 12 volt rechargeable batteries in there.
That's right.
But everything else, including the impeller and the pump itself, has all actually been 3D printed.
Yes, all designed to make one complete unit.
Yeah. Shall we give it a try quickly?
Yes.
All right, let's see. Fit it onto my face. I'm going to clip the high density foam at the back of my head, which is actually very easy to do. I'm going to tighten it so that I'm happy that it seals nicely under my chin, and that it sits nicely around my face. It gives me a positive airflow. The pump gets basically connected to the back, to my back, and now the airflow from here is always inwards to outwards, so no viral particles can come here. If someone coughs or if I'm busy doing an operation and some splatter happens, this shield is going to protect that splatter from getting onto my nose and my mouth and my eyes. And even if there's aerosolized viral particles, it's not going to be able to get in here because there's constant air flowing out from my face, out from the mask. So this really protects me against the worst type of scenario of airborne particles that could be around me. And it's very easy to breathe, whereas with a normal mask, it's quite difficult if you want to inhale and the mask is quite effective. It makes it quite difficult to inhale with this because it's pumping air into my mask the whole time. I'm not struggling to breathe at all, and I don't fog up. I can wear my glasses underneath here. So the idea is that I can really use this. I can work a couple of hours without putting extra strain on my breathing and on the way that I work. And when I'm finished and I want to clean, I basically take the mask off. And I can wash this mask with my hands in the basin with normal antiseptic hand washing lotions. All of this stuff is washable and none of it is going to become soggy. It'll dry quite quickly and ready for use the next time around. So the idea is that this is a reusable product so that you don't throw it away like we do normal masks, and we're not going to run out. And if we can produce this at a price that is affordable within our economic setting, then it means we can hopefully supply this to our healthcare community quite easily. So yeah. Okay, Retief, so when you're not busy designing masks to help us surviving this whole thing, maybe just give me like a one minute rundown on what your normal business entails. Where's your business located? What type of things do you do?
Yeah, we are a small consulting business in Stellenbosch. Name is RKID. We focus to solve problems, and it's more or less around products. Products that needs to go into mass production or something where there's a technology lack, we sort of look at the technology side and then take the technology over into a product and a product application. And this might be in the agricultural, it might be in medical, it might be in mining, it might be even in the retail. We've got quite a broad spectrum of different applications, and our customer base is almost all around the world. Although we do a lot of local products, we do stuff in Australia at the moment. We do a Switzerland project, and we also handle the manufacturing. So for any product design, there's always a big relationship with whoever's going to produce the parts. And for us, it's really important to know your production methods, you know your material quite well, because if you've got a happy manufacturer, you've got a successful product. And so we involved ourselves in the managing and coordinating of all the different manufacturing components locally or abroad, and we help to get parts and components back to South Africa and on the shelves to sell.
Fantastic. On your website, you're going to basically post the CAD files?
Yeah. So we've opened up a file on our website as part of our contribution towards COVID, is to supply the design of this as an open source design into the community. So if there's makers that can assist 3D printing, or people can cut, most of the designs are almost maker friendly. The profiles are all designed to fit on an A4 sheet. So if you have an A4 printer and you can print it onto a paper and you can cut it with a pair of scissors, that was the intention, is to try and get a design out there that's really low tech in a way that anybody can make it from the stuff that you might have at your house.
Okay.
Yeah.
So we'll post the link to the website below. So please, when you finish watching the video, click on the link below. Please give us a thumbs up on this. It just goes to show that you might not be a doctor or a nurse or a healthcare practitioner, but you can still make a difference in terms of fighting this pandemic. And this is something that now theoretically can help people all over the world, because anybody with this type of technology can actually build this in their country. They don't have to import it, and I think that's the whole idea. So I want to commend you and say thank you very much for your effort that you've made in this whole fight. And may God bless South Africa. We'll chat again. Please subscribe, click the bell, and I hope you have a wonderful and a safe weekend.
Thank you.
Thanks.